This image shows the actual size of Typhoon Tip compared to the contiguous United States. In October 1979, this super typhoon grew to enormous proportions, challenging our understanding of tropical cyclones. October 4th, 1979. A day that began like any other in the western Pacific near the island of Pohnpei in Micronesia. Meteorologists observed the formation of a tropical depression, one of many that typically form in this region each year. As the system began to organize, an unexpected obstacle appeared. Tropical Storm Roger, another system in the vicinity, interfered with its development, disrupting airflow patterns and competing for available energy. This initially stunted the growth of the future Typhoon Tip. However, a combination of meteorological factors soon aligned to create the perfect environment for explosive growth. Exceptionally warm sea surface temperatures provided abundant energy, while an area of high pressure to the north helped steer the system and maintain its organization. These conditions allowed the depression to overcome Roger's influence and begin a period of rapid intensification. By October 8th, the system had been upgraded to Tropical Storm Tip, with maximum sustained winds of 65 miles per hour. Its forward speed increased, and the storm began to curve towards the northwest. Satellite imagery revealed a well-defined eye forming at the center of the circulation, signaling further intensification. Meteorologists tracking Tip noticed something unusual. The storm was not only intensifying rapidly, but also expanding in size at an unprecedented rate. Its wind field grew larger each day, extending its reach across an ever-widening area of the ocean. By October 11th, just a week after its formation, Tip had undergone a remarkable transformation. It achieved super typhoon status, with maximum sustained winds exceeding 150 miles per hour. The once unremarkable weather system had become a meteorological behemoth, its eye clearly visible from space as it churned across the western Pacific. As Tip continued to strengthen, meteorologists worldwide took notice. Instruments designed to measure tropical cyclones registered readings that pushed the boundaries of what was thought possible. It became clear that they were witnessing something truly extraordinary, a storm that would challenge our understanding of the very limits of tropical cyclone intensity and size. Building on our introduction, Typhoon Tip's unprecedented size and intensity pushed the boundaries of tropical cyclone behavior. As the storm developed on October 12th, it began breaking records across all key measurement categories. Meteorologists typically assess tropical cyclones using central pressure, wind speed, and size. Tip's measurements in these areas were extraordinary. The storm's central pressure plummeted to levels never before recorded, while its wind field expanded rapidly. Maximum wind speed soared, creating a perfect storm of record-breaking conditions. Tip's sheer scale posed significant challenges for meteorologists of the time. Traditional measurement methods struggled to capture the full extent of the storm. The typhoon's wind field eventually grew to cover an area equivalent to half the contiguous United States, spanning 1,380 miles in diameter. The potential impacts of such a massive storm were difficult to fully grasp. A typhoon of this size could affect entire regions simultaneously, with its outer bands capable of causing significant damage hundreds of miles from the eye. This combination of size and intensity raised serious concerns about widespread devastation if Tip were to make landfall at full strength. At its peak, Typhoon Tip's central pressure dropped to 870 millibars, the lowest ever recorded in a tropical cyclone. This extreme low pressure contributed to maximum sustained winds of 190 miles per hour, strong enough to completely destroy most structures in its path. The storm's eye, measuring 9.3 miles wide, was clearly visible from space. These record-breaking characteristics represented a fundamental shift in our understanding of tropical cyclones. Tip's unprecedented intensity and size challenged existing models and forecasting techniques, prompting a re-evaluation of how we prepare for and respond to extreme weather events. As Typhoon Tip reached maximum strength, attention turned to its potential path and impacts. The storm's enormous size meant that even a glancing blow could have catastrophic consequences for populated areas. Meteorologists and disaster response teams braced for what could be one of the most significant weather events in recorded history as Tip continued its journey across the western Pacific. Typhoon Tip's behavior after reaching peak intensity was unusual. While most tropical cyclones quickly lose power, Tip maintained much of its record-breaking strength for an entire week. Puzzling forecasters, the storm's longevity was primarily due to its enormous size and favorable environmental conditions. Tip's massive wind field acted as a vast energy reservoir, allowing it to draw upon extensive warm, moist air resources. This self-sustaining system helped Tip resist typical weakening processes. A tropical upper tropospheric trough also supported the storm's intensity by providing excellent outflow channels. As Tip slowly moved across the western Pacific, its decreased forward speed allowed it to linger over warm waters, preserving its strength. This prolonged high-intensity period posed significant challenges for forecasters, who had to continuously adjust their predictions.
Techniques of creating such weather models and all the different aspects that go into forecasting.
The persistence of Tip's extreme intensity raised concerns about its potential impact on land. As the storm approached Japan, disaster response teams and local authorities prepared for a typhoon that had maintained much of its record-breaking power for an unusually long time. Eventually, as Tip neared Japan, it began to weaken due to cooler waters and increased wind shear. However, when it made landfall on October 19th, it was still a powerful storm, with winds of about 80 miles per hour or 130 kilometers per hour. This demonstrated Tip's remarkable staying power, having maintained significant strength over thousands of miles in nearly 2 weeks since reaching its peak. The storm's unusual longevity had allowed more preparation time, but it had also increased anxiety. With Tip finally about to interact with populated areas, its true destructive potential was about to be revealed.
There were surging waves.
Typhoon Tip's landfall in Japan on October 19, 1979 brought significant consequences despite weakening from its peak intensity. The storm's effects were widespread, with heavy rainfall and strong winds causing extensive damage across the country. The immediate impacts were severe, with flooding as the primary concern. Numerous mudslides occurred, urban drainage systems were overwhelmed, and thousands of homes were inundated. Many families were forced to evacuate as floodwaters rose. At Camp Fuji, a U.S. Marine Corps base, a tragic incident unfolded during the typhoon. A catastrophic fire resulted in the loss of 13 U.S. Marines' lives and injured 68 others, highlighting the unpredictable nature of extreme weather events. The overall impact on Japan was substantial. The storm claimed 86 lives and caused significant damage to infrastructure, including bridges and dikes. Agricultural and fishing industries were heavily affected. The total damage amounted to approximately $482 million. As Tip moved inland, it transitioned into an extratropical cyclone, marking the end of its tropical phase. However, its legacy was just beginning to take shape. The storm's impact extended beyond its immediate aftermath, influencing typhoon preparedness and response strategies globally. Emergency management agencies reassessed their protocols, and engineers incorporated lessons from Tip into the design of flood control systems and critical infrastructure. Typhoon Tip's legacy continues to inform our understanding of tropical cyclones and shape our approach to storm preparation and response. As we face ongoing climate challenges, the knowledge gained from this historic storm remains invaluable in our efforts to mitigate the impacts of future extreme weather events. Typhoon Tip's unprecedented size and intensity reshaped our approach to tropical cyclone research and preparedness. Its legacy endures in improved forecasting models and more robust disaster response strategies. As climate patterns shift, the insights gained from Typhoon Tip become increasingly relevant. The storm's extraordinary characteristics underscore the importance of continued vigilance and investment in meteorological research. Studying such extreme events enhances our ability to protect vulnerable communities in the face of future challenges. Looking ahead, a critical question emerges. How will our understanding of powerful storms shaped by events like Typhoon Tip influence our response to future meteorological phenomena? While we cannot predict with certainty whether Tip's records will be surpassed, ongoing scientific inquiry remains crucial. Our evolving knowledge of these natural forces will play a vital role in navigating the complexities of extreme weather events in the years to come. Please like and subscribe for more incredible hurricane stories. Thanks for watching.